Let us learn few differentiation formulae. The formulae which we are going to write, these formulae can be derived using first principle method. The first one, differential of a constant is 0. Second formula, differential of x raised to n will be n into x raised to n minus 1. For example, differential of x power 1 it is. So 1 into x power 0. X power 0 is 1. Or differential of x square will be 2 times x power 1, which is 2x. Then third formula, we will write for all trigonometric functions. D by dx of sin x is cos x. D by dx of cos x is minus sin x. D by dx of tan x is secant square x. We will memorize the direct formulae for all trigonometric functions, and d by dx of cot x is minus cosecant square x. D by dx of secant x is secant x into tan x, and d by dx of cosecant x is minus cosecant x into cot x. Be thorough with all these differentiation formulae. Now we are going to do the differentiation questions using these formulae. Only when the question says by first principle method, we use first principle formula. Otherwise, we can do direct differentiation. Algebra of derivatives. If you have sum of two functions, to find the derivative of sum of two functions, we can do derivative of each term and then add. Similarly for subtraction. Second one, product rule. If you have product of two functions, to find the derivative of the product, the formula is u dash v plus u v dash. These formulae can be derived using first principle method. Then we have quotient rule. U divided by v the whole dashed is equal to u dash v minus u v dashed. K times u the whole dashed. That is, if you have constant into a function, to differentiate this, constant can be taken out and only function can be differentiated. If you have only constant, its derivative becomes 0. Memorize quotient rule and product rule formulae. We will do exercise 13.2. Direct differentiation we are going to use. The first question, find the derivative of x square minus 2. So d by dx of x square minus 2. Direct differentiation, because the question doesn't say by first principle method. Differential of x square is 2x using n into x power n minus 1 formula, and derivative of a constant is 0. The answer is 2x. Now we have to find the derivative at x is equal to 10. Therefore, f dashed at 10 is equal to 2 times 10. The answer is 20. Similarly, the second question. Let us take the given function as f of x, which is 99x. So f dashed of x is 99 into differential of x with respect to x is 1. If you have a constant and a function, take out the constant and differentiate only the function. Now f dashed of 100 at x is equal to 100 we have to find. It is a constant, so it remains as a constant. Third question. Find the derivative of x. So let us take the given function as f of x. Now f dashed of x. Derivative of x is 1, we know. And we have to find x when x is 1. Again, this is a constant, so the answer is 1. Fourth question has been done under first principle method already. Now question 5. For the function f of x, which is x raised to 100 over 100 plus x raised to 99 over 99 plus etc. plus x square over 2 plus x plus 1. Prove that f dashed of 1 is equal to 100 times f dashed of 0. So let us first find f dashed of x. 1 by 100 is a constant. So take out that constant and let us differentiate x raised to 100. So n into x power n minus 1 formula. 100 minus 1 is 99 plus 1 by 99 is a constant. Let us differentiate x raised to 99, which is 99 x raised to 98, etc. Half is a constant. Derivative of x square is 2x. And derivative of x is 1. Derivative of constant 1 becomes 0. Now these numbers are getting cancelled. Therefore, f dashed of x is x raised to 99 plus x raised to 98, etc. x and plus 1. We will find f dashed of 1. 1 raised to 99 is 1. 1 raised to 98, etc. x is 1 plus 1. We have 100 terms in this. Here x raised to 1 till 99, the power. And then this one, we have totally 100 terms. Therefore, the answer becomes 100. Now, f dashed of 0, let us calculate. So, all these terms will become 0. Last term is 1. Therefore, the answer is 1. Therefore, f dashed of 1 is equal to 100 times f dashed of 0. Question 6. Find the derivative of x raised to n plus a into x raised to n minus 1 plus a square into x raised to n minus 2 plus etc. a raised to n minus 1 x plus a raised to n for some fixed real number a. So a is a constant here. Let us take this as f of x. So we will find f dashed of x, which is equal to differential of x raised to n is n into x raised to n minus 1. A is a constant. Differential of x power n minus 1 is n minus 1 x power n minus 2. N minus 1 minus 1. It becomes power n minus 2. Next term, a square n minus 2 times x power n minus 2 minus 1. You have to reduce the power by 1. It becomes n minus 3 plus etc. A raised to n minus 1 is a constant. Differential of x is 1 plus a power n is a constant. Derivative is 0. This is the answer. We need not write plus 0. I remove that term. Question 7. First subdivision. We will take the given expression as f of x, which is x minus a times x minus b. Two methods are there to do this. We can open the brackets, get the expression, and each term can be differentiated, or we may use product rule. Let us practice product rule. We will take u and v. The product rule formula is uv the whole dashed is u dash v plus uv dashed. So f dashed of x is equal to x minus a the whole dash into v plus u into differential of x minus b. Let us differentiate and write. Differential of x is 1 and differential of a is 0. So 1 minus 0 is 1. 1 into x minus b plus x minus a into differential of x minus b. Differential of x is 1, differential of b is 0. 1 minus 0, which is 1. Therefore, the answer is 2x minus a minus b. 7th question, second subdivision. F of x is equal to ax square plus b the whole square. We can expand and do, or we may use chain rule. Let us expand. A square x power 4 plus b square plus 2ab square. Now let us differentiate. F dashed of x is, a square is a constant, keep the constant and find the differential of x power 4, which is 4x cube. B square is a constant, derivative becomes 0. 2ab is a constant and differentiate x square, which is 2x raised to 1. Therefore, the answer is 4a square x cube plus 4abx. 4ax is common. We get ax square plus b. Third subdivision. F of x is equal to x minus a divided by x minus b. We will use quotient rule. U by v the whole dash is u dash v minus uv dash divided by v square. U is the numerator and v is the denominator. U dash into v minus u and v dash, which is equal to differential of x is 1, differential of a is 0. 1 minus 0 is 1 into x minus b minus x minus a times again 1 minus 0, which is 1. Use brackets. X minus b the whole square. Minus x and plus x are getting cancelled. Minus of minus a is plus a and we get a minus b in the numerator divided by x minus b the whole square. Question 8. Find the derivative of x raised to n minus a raised to n divided by x minus a for some constant a. Here also we are going to use quotient rule. U by v the whole dash is u dash v minus uv dash divided by v square. Quotient rule has minus sign in between. Therefore, f dash of x is equal to u dash into v minus u and v dash divided by v square. Let us find the derivative. Derivative of x raised to n is n times x power n minus 1 and a power n is 0 into x minus a. Use brackets and we have x power n minus a power n times. Let us differentiate x minus a. Differential of x is 1, differential of a is 0. 1 minus 0 is 1 divided by x minus a the whole square. Let us open the brackets. N into x raised to n minus 1 into x. Powers should be added. Therefore, it becomes x raised to n minus the second term, a n x raised to n minus 1 minus x raised to n, minus of minus is plus a raised to n divided by x minus a the whole square. These two are like terms. It becomes n minus 1 times x power n minus a n x power n minus 1 plus a raised to n divided by x minus a the whole square. Ninth question, first subdivision. F of x is equal to 2x minus 3 divided by 4. F dashed of x is equal to differential of 2x. Keep the constant 2 and find the derivative of x. Differential of x is 1. And 3 by 4 is a constant. Differentiation is 0. Therefore, the answer is 2. Second subdivision. The given function is 5x cube plus 3x minus 1 times x minus 1. We can open the brackets and differentiate each term, or we can use product rule, u and v. uv the whole dashed is u dash v plus uv dash. Therefore, f dashed of x is equal to u dash into v, write the terms within brackets, plus u and v dash. Let us differentiate. 5 is a constant and differential of x cube is 3x square n into x power n minus 1 formula. 3x, keep the constant and differentiate x, which is 1, and derivative of 1 is 0, times x minus 1 plus 5x cube plus 3x minus 1. Let us differentiate x minus 1. Differentiation of x is 1. 1 minus 0. Derivative of 1 is 0. 1 minus 0 is 1. Let us open the brackets. 15x square into x is x cube minus 15x square plus 3x and minus 3. And the second bracket, 5x cube plus 3x minus 1. Let us add the like terms and write. We have 15x cube and 5x cube. Therefore, it becomes 20x cube. We have only one x square term, so minus 15x square. 3x plus 3x is 6x and minus 4. Third subdivision, very simple function. F of x is x raised to minus 3 times 5 plus 3x. So here we can use product rule, or we may multiply and differentiate each term. Here multiplying and then differentiating will be easier, because you have only one term outside, so multiplication is easier here. 5x raised to minus 3 plus 3 times x raised to minus 3 into x raised to 1. Add the exponents, so it becomes x raised to minus 2. Now we are going to differentiate. F dashed of x is 5 into, let us differentiate x raised to minus 3 using n into x power n minus 1 formula. We get minus 3 x raised to minus 3 minus 1, which is minus 4, plus 3 times minus 2 x raised to minus 2 minus 1, which is minus 3. The answer is minus 15 x raised to minus 4 and minus 6 x raised to minus 3. We can take minus 3x raised to minus 4 common. We get 5 from the first term and plus 2x, which can be written as minus 3 divided by x raised to 4, 5 plus 2x. Fourth subdivision, same type. F of x is x raised to 5 into 3 minus 6 x raised to minus 9. Let us open the brackets. You have only one term outside, so multiplication will be easier. 3x raised to 5 minus 6x raised to minus 4. 5 minus 9 is minus 4. F dash of x is equal to 3 into differential of x power 5 is 5 times x power 4 minus 6 into differential of x raised to minus 4 is minus 4x raised to minus 5. Minus 4 minus 1 is minus 5. 15x raised to 4 plus 24 divided by x power 5. This is the answer. If you want, you may take the common factors out or leave it in this form. Ninth question, fifth subdivision. F of x is equal to x raised to minus 4 into 3 minus 4x raised to minus 5. We will open the brackets. 3 times x raised to minus 4 minus 4 times, add the exponents, minus 4 minus 5 is minus 9. Now let us differentiate. F dash of x is equal to 3 is a constant. If you have constant into a function, we keep the constant and we differentiate only the function. So minus 4x raised to minus 4 minus 1 becomes minus 5. Minus 4 times minus 9x raised to minus 9 minus 1 is minus 10. We get minus 12 divided by x raised to 5, and this is plus 36 divided by x raised to 10.
We may leave the answer in this form, or we may take the common factors out and write. The common factor is 12 by x raised to 5. From the second term we get 3 divided by x raised to 5, and from the first term we get minus 1.
Sixth subdivision. F of x is equal to 2 divided by x plus 1 minus x square divided by 3x minus 1. We can use quotient rule for each term, or you may take LCM, simplify and then use quotient rule, but doing quotient rule separately will be easier for this question. Quotient rule formula, u by v the whole dashed is u dash v minus u v dash divided by v square. F dash of x is equal to, let us use quotient rule for the first term. U dash differential of 2 into x plus 1 minus 2 times derivative of x plus 1 minus quotient rule for the second term. U dashed is x square dash times 3x minus 1 minus x square times derivative of 3x minus 1. Derivative of 2 is 0. So the first term becomes 0 minus 2 times differential of x is 1 and differential of 1 is 0. 1 plus 0 is 1. So 2 into 1 is 2 divided by x plus 1 the whole square. You could have differentiated this term by writing it as 2 times x plus 1 whole raised to minus 1. So it is 2 times minus 1 x plus 1 whole power minus 2. This is the derivative. So you may differentiate like this also. Minus derivative of x square is 2x and we have 3x minus 1, use brackets, minus x squared times derivative of 3x, 3 into 1 and minus 0, derivative of 1 is 0, divided by 3x minus 1 the whole square. Let us simplify the second term. Open the bracket, 6x squared minus 2x minus 3x squared over 3x minus 1 the whole square, minus 2 divided by x plus 1 the whole square, 6x squared minus 3x squared will become 3x squared and minus 2x divided by 3x minus 1 the whole square. 10th question we already did under the first principle method. Now question 11, first subdivision. Find the derivative of the following functions. F of x is equal to sin x into cos x. We will use product rule here. uv the whole dashed is u dash v plus uv dash. F dashed of x is equal to sin x dash into cos x plus sin x into cos x dash. We know that derivative of sin x is cos x into cos x plus sin x into derivative of cos x is minus sin x. So we get cos square x minus sin square x, which is cos 2x. Second subdivision, f of x is secant x. Derivative of secant x is secant x tan x. Or you may write it as 1 by cos x and use quotient rule. We know the direct formula for all 6 trigonometric functions. So the derivative is secant x into tan x. Third subdivision, f of x is 5 secant x plus 4 cos x. We have direct differentiation formula for both the functions. 5 is a constant, keep it, and derivative of secant x is secant x tan x plus 4 times differential of cos x is minus sin x. Therefore, the answer is 5 secant x into tan x and minus 4 sin x. Fourth subdivision, f of x is cosecant x. Be thorough with all the differentiation formulae, and derivative of cosecant x is minus cosecant x into cot x. We have continuation of differentiation lesson in 12th standard. Now fifth subdivision, f of x is 3 cot x plus 5 cosecant x, and f dashed of x is derivative of cot x is minus cosecant square x. So it becomes minus 3 cosecant square x, and derivative of cosecant x is minus cosecant x into cot x. Therefore, this sign becomes negative, minus 5 cosecant x into cot x. Sixth subdivision, f of x is 5 sin x minus 6 cos x plus 7. The derivative is 5 into derivative of sin x is cos x minus 6 times derivative of cos x is minus sin x, so minus of minus will become plus, and derivative of 7 is 0. Seventh, f of x is equal to 2 tan x minus 7 secant x. Therefore, f dash of x is derivative of tan x is secant square x minus derivative of secant x is secant x into tan x. Example 22, first subdivision, f of x is equal to x raised to 5 minus cos x divided by sin x. F dash of x is equal to, we will use quotient rule, x power 5 minus cos x dash into sin x minus x power 5 minus cos x into sin x dash divided by sin square x. Derivative of x power 5 is 5x power 4. Derivative of cos x is minus sin x. Therefore, minus of minus plus sin x into sin x minus x raised to 5 minus cos x multiplied with derivative of sin x, which is cos x, divided by sin square x. Let us open the brackets. We get 5x raised to 4 sin x plus sin square x. Distribute the negative sign. X power 5 cos x and minus of minus is plus cos square x divided by sin square x. We can use the identity for sin square plus cos square. The answer is 1. We get 5x raised to 4 sin x minus x raised to 5 cos x, and this becomes 1 divided by sin square x. Now the second subdivision of example 22. F of x is equal to x plus cos x divided by tan x. Write the quotient rule. U dash into v minus u into v dash divided by tan x the whole square can be written as tan square x. Derivative of x is 1. Derivative of cos x is minus sin x times tan x minus of x plus cos x times derivative of tan x is secant square x divided by tan square x. Even if you open the brackets, we cannot simplify. So let us leave it in this form. This is the answer. Let us learn chain rule. In 11th syllabus, we don't have chain rule, but some of the questions are given which can be done using chain rule in the miscellaneous exercise. To learn about chain rule, we should know about the composition of two functions. Composition of two functions produces another function, and it should be written as u of v of x. So first we will find v of x. For that, u function has to be calculated. For example, let us consider u function as 2x plus 3 and v function as root x. Then u of v of x will be u of v of x is root x and u function u of root x will be 2 times root x plus 3. That is, you have to replace x by this root x in the definition of u of x. Let us find composition of v and u. V of u of x, which will be v of u of x is 2x plus 3 and v of 2x plus 3. We are going to use this definition. Here in place of x, we have 2x plus 3. Therefore, it becomes root of x should be replaced by 2x plus 3.
You will be learning about composition of functions in detail in 12th standard. Composition of two functions means function of a function. It is not product of those two functions.
Now let us see how to differentiate composition of two functions. If you have u of v of x, to find the derivative of this, the outer function has to be differentiated, keeping the inner function same. Then the next level, the inner function has to be differentiated and then x has to be differentiated. Differential of x is 1. So remember, the outer function should be differentiated first. And then the inner function has to be differentiated. This is known as chain rule. See example 18. F of x is given as sine square x. It can be taken as sin x into sin x and you can use product rule, or let us differentiate directly using chain rule. This is sin x whole power 2. So the outermost function is that square function. Power has to be differentiated first using n into x power n minus 1 formula. So it becomes 2 sin x whole raised to 2 minus 1. 2 minus 1 is 1. Into the next level, the base has to be differentiated, which is differential of sin x is cos x. So 2 sin x cos x becomes sin 2x. Example 21. We'll do the first subdivision. F of x is sin 2x. This is also composition of two functions here. We will use chain rule to differentiate this function. The outer function is sin x, the inner function is 2x here. Whereas in the previous question, the outer function was square function and the inner function is the sin x function. Here this is the outer function and this is the inner function. So we'll differentiate the outer function first. Differential of sin x is cos x, we know. Here we have sin 2x, therefore it should be written as cos 2x into differential of the inner function. Differential of 2x is 2. Therefore the answer is 2 cos 2x.